To give you a little bit of history, San Bernard installed their first AMR systems in 1989 for getting the monthly remote meter readings back to the office. As time and technology evolved, we started getting daily interval readings back to the office. Then we integrated these one-way power line carrier systems to our outage management system in 2002. Now we could ping a meter and sometimes get results back telling us if that meter was indeed out. These AMR systems served us very well. However, we were asking them to do things they weren't designed to do, and the results were not always producing the desired outcome. The AMR systems had reached the end of their life cycle, and it was time to reinvest in either upgrading them or discover what else might be out there. We began our search almost 3 years ago. We looked at many backhauls and solutions. We piloted a few different programs and had multiple propagation studies performed. We ruled out WiMAX, cellular, power line carrier, and unlicensed RF mesh as our backhauls, and decided on a licensed RF mesh system. In this case, it was Sensus. Well, as we began our search, the buzzword of smart grid was out there, and we had to determine and define what was smart grid to us. And we wanted the next generation AMI to enhance our existing systems and provide information in a way that met our definition of smart grid. The last generation AMR system had been in place for 20 years. Could we really find a replacement with equal shelf life that can keep up with these technology changes? After all, would you want to use a cell phone that's 20 years old? The next generation AMI must take full advantage of existing technologies with a culture of commitment in working with our existing vendor solutions. They must play well in our sandbox. They must have long-term sustainability. They must utilize standards when possible. Custom integration equals increased hidden costs, delays in implementation with increased support. We wanted to remove as many of the custom Band-Aid solutions that were in place today as possible. We also wanted to approach this in a way as to set an example and be the industry leader in this. We wanted to be able to take the cookie cutter approach, where the processes that we put in place at our place could be taken and applied at your utility and get the similar or if not the same desired results. Now, the main standard that we've been utilizing was multi-speak, and it had been very successful with our existing solutions. So we wanted to utilize multi-speak for this new solution as well. Now, multi-speak will not answer all of our integration needs today, but we want to utilize it where it does. Where it does not meet our needs, we're talking with vendors and with the multi-speak organization to see if future development can fill in those gaps. We are using machine-to-machine batch processing in some cases. For instance, the ship file that comes with each shipment of meters is batch dumped into our inventory system. In this case, it's NISC. The meter exchange follows similar processes as we deploy them to the field. We have a daily interval read file that is batch uploaded to our billing system each day. This was a custom query with scheduled tasks running inside of SQL. For our MDMS, we are taking full advantage of the CMAP and MLA standards. Alarms are sent over to our outage management system and field viewers through some custom SQL that I wrote. Blink counts are gathered and stored as a daily reading to a SQL table. I will be running some deltas against the blink counts, comparing them to outages in the area to determine needed action to improve the quality of service for those areas. With our previous solutions, each meter change required touching multiple databases to get the systems to know all that has happened. With this solution, using multispeak, as the CSR goes about doing her normal job functions, the AMI systems is kept in sync. As a meter change is processed in our billing system, the AMI system is updated and reflects that meter change in real time. This video will show that happening. The purpose of this video is to show the multi-speak integration between NRTC and Sensus, where when we install a meter in the NRTC system or do a meter exchange, it will automatically, using the multi-speak methods, place the meter into the install state inside of the Sensus software. If you see right now, this particular meter is in inventory. It's not installed. We're going to go into iView, in NRTC's iView software, and we're going to do a meter exchange process service order. And that meter exchange process service order is going to automatically change that meter from inventory to installed. I'm going to save that, close the service order, and then move over to the Sensus RNI. You see there's the ingoing meter first with the new meter number that represents the Sensus meter and the outgoing meter number. So it was successful in the iView system, so now let's move over to the RNI system and see if the state has changed from inventory back to or into installed. So right now it still says inventory, so it takes a few minutes. It's not right away because it's not a top priority, but there you see it said moved from inventory to installed. Okay, now I want to show how you can do an on-demand read using the multi-speak methods inside of NRTC's iView, and it'll take about 9 seconds once you hit the read now for the reading to show up, and it's going out through the Sensus system and grabbing the reading. Pay attention to that top line there. You see a new reading just showed up. The next video demonstrates the ability to connect and disconnect the meter from within our billing system and automatically through multi-speak processes. This is used extensively for managing our disconnects for non-pay. We're also going to use this same technology to offer prepay to our members. When the member pays their bill online through multi-speak, the meter is automatically reconnected without the need to contact a human in the office. We're going to show the integration of Sensus to NRTC for the connect-disconnect. This particular meter is right now connected. We're going to issue a service order to disconnect the meter inside of iView, and through the multi-speak methods it will go across and disconnect the meter and display that in the Sensus software. So here's generating the service order, standard steps for that. Now this can also be done in the delinquent collections page, where you're choosing which ones need to be disconnected and send them all over in mass. But for the purpose of this demonstration, we're just doing one test meter. So we're doing it through a service order. So right here, when we choose on that hyperlink disconnect, then it brings up this screen. Now the first thing I'm going to do is use the multi-speak methods to get the reading, the latest reading out of the database. So I'm using a read now. Okay, so there's the reading. I'll select that reading and I'll hit OK. It fills in the value. This is a test meter, so the value is 0. Okay, now we hit disconnect. Now as soon as we click over back onto the Sensus software, it'll show that it's been disconnected. We hit OK there. We hit OK here. I'm looking to see if there's any alarms listed about it failing, and I see no alarms. So when we come over here, I'm going to refresh this page, and you see it went from the status of connected to disconnected. And now we're going to talk about outage integration. Now this is an example where every meter called in within the first 2 minutes. We have 13 meters behind this tap fuse, and they all called in. Now we have our the super caps set to report in after 64 seconds that it's an outage, so that we don't wind up with a bunch of false outages from momentaries or have them delay too long to where those super cap dies and it's unable to report it in. Seems to be the right combination for us and for our system. So here's that same outage, and you notice there's we've got a truck. This is truck 59, and through AVL, integrated AVL, we can see the trucks driving live on the map. He has already restored this outage. They just haven't restored the outage ticket yet, and all the meters have already reported back in that they're back on. We did receive one manual phone call here, and then one Porsche IVR call here during that time. So, and you know, it may have taken much longer for those phone calls to come in, and the outage system is only as smart as the information you feed it. And the more information and the more accurate that information is, the better it can do its job. So in this case, we knew much sooner than we would have known otherwise. Now this video is going to demonstrate, using the model connectivity, how we can ping meters downstream from a protective device. The amount of time it takes to ping the meters will vary depending on the backhaul network traffic. I've pinged as many as 500 meters, received the answers within 90 seconds. Those same 500 meters have taken as long as 5 minutes, with some of them timing out after time because of the network being busy. But most of the time, the results are come back within 90 seconds or so. Here's another example of an outage where all the meters have called in before we received a single phone call. This particular outage also had a SCADA device report the lockout because it was on the high side circuit switcher T1 inside the substation. And this was about 90 seconds into the outage. Here, not all the meters were successful at reporting the power outage to the system. Like I mentioned, these supercaps are programmed with it on board so that they'll blast out a message about the outage at a particular program time. And we've got that set to 64 seconds. And this gives the breakers time to do their job and not create false outages. So notice there's no manual phone calls on this map yet. And now let's talk a little bit about the analytics of alarms. I wrote some SQL code to look at the alarm view in the Sensus database and present them as a note on the screen. That note is given an immediate expiration date and timestamp. The dispatcher receives an audible alarm as well as a symbol on the meter on the map within the dispatch outage management system. So here's the symbol, and there's the alarm that shows up. And then he also gets an alarm that he must acknowledge by sound. Now once the alarm is dealt with and it's closed, it becomes a permanent historical record for that meter location. This is very helpful in determining every time we have heard from that location, by a human phone call or by the IVR calls or by the meter alarming us. Sensus only keeps 60 days of history within their database. Therefore, we need to be storing that off for analytics of those alarms in another system, and we're doing that with our outage management system. This is an example of where the dispatcher received a hot socket alarm. The service crew was on the scene within 20 minutes of receiving this alarm. The service crew reported the meter was too hot to even touch, and they determined there to be a short within the underground service entrance below the meter to the house. So it was red tagged as a hazard. The member was notified. That evening he had the situation resolved, and we had the power turned back on for him. And we would have never known about it until after the fire department was calling us to tell us. All of these meters reported in at the same time, and they all reported in high volts. They also were all on the same phase. I will switch over to color by phase and to show that. They were all on A phase. So all A phase, all high volts. And there's a regulator that sits right here. And so they were all behind that same regulator. So once they got the alarms in, then they reported it to our technical services group. You see here they all are. And there were 16 meters that all reported in at the same time. Once they got those alarms in, they sent the technical services group out to the regulator. And what they found, Brent Wilkie got out there and bypassed the regulator. First, he found the hands were all on 16 boost. So he manually lowered the voltage at the regulator, and then bypassed the regulator because he found the regulator controller was bad. This all happened within 1 hour between when the alarms came in till the regulator was actually bypassed and the problem was corrected. Communications to our membership has been spectacular, I'd have to say, on this project. We've done a great job communicating to our members, and I have to give our communications department credit for that. So we're seeking complete transparency and honesty with our membership. We're addressing each concern individually as we're made aware of it. There's only been a handful so far, by the way. And we communicate to our memberships as a whole through our monthly newsletter. We also highlighted this project at our annual membership meeting. A few weeks before arriving to a specific area, the member receives a postcard notifying them of the upcoming meter change. A few days before arriving on their property, the automated phone system, the IVR, calls that member and lets them know that we're about to enter their property within the next few days. Once we've entered their property, if we were successful at changing the meter, then a green door hanger is put on their door. If we were not successful, then the red door hanger is put on there, and we follow up with a phone call to talk to the member about making arrangements. Now, all of this information is also readily available on our website. We have an interactive AMI meter deployment map on our website available to the public. When you click there and you click under AMI meter deployment maps, this page comes up. You can then type in a 911 address and see when are you scheduled for, or has your meter been set. That's one of the questions that's asked often of us, is when are we getting that new meter. You type in the 911 address and you see a pin shows up right there, so it's showing that that one is scheduled for July. And you can also right click and then say zoom to, and it shows it zoomed in as well, scheduled for July. It's using Bing Maps for the background, and then using ESRI for the layers, and just pushing it through our firewall using our ESRI licensing. So you may ask, how are the members accepting this new technology? Well, I know this doesn't tell the full story, but our ACSI score since beginning this project has climbed from 86 to 90. We're pretty proud of that.